Hello and welcome to Go Get a Geeks. I'm Aditya Solge and in this video I'm going to simplify recursion using Java. While I'll be using Java to explain recursion in this video, the concept remains the same across all programming languages. But before we dive into recursion, let's first understand what happens behind the scenes when a program is executed involving calls to functions. Here we have a Java program having two functions, main and add. When the execution begins, main function is pushed onto the stack. Now, if you're not familiar with the stack, simply consider a stack of plates in a restaurant. The plate at the top will be picked up first and so on, meaning the plate which was put last on the stack will be picked up first, and hence in programming, a stack is said to be a last in, first out data structure. Now, coming back to our example, main function will be pushed onto the stack and then execution begins line by line. So let's say here is our stack and the main function gets pushed here. Now on the first line, we are requesting for a memory block which is capable of storing integer values. So a memory block will be allocated. Let's say it has an address of 1000 and the variable a will be pointing to this memory block and it will have a value of 10. Now the control moves on to the line number 2 and here another memory block, let's say 2000 gets allocated and a value of 20 and a variable named p will be pointing to this memory block. Now on line number 3 we are making a call to add function. So at this point in time the add function will now be pushed onto the stack, and before the execution begins, so we see there are two variables that the add function takes in. So the memory block for each of them, let's say 3000 and 4000 will be allocated and n1 and n2 will be pointing them. And the value which is passed from main function, which is the values pointed by variable a and b, which is 10 and 20, will be copied onto these two memory blocks. Now the execution of add function begins and on line number 1 a memory block, let's say having an address of 5000 is allocated and the result variable is now pointing to this. On this line the values pointed by variables n1 and n2, which is 10 and 20, will be summed up and is stored at the memory block which the result is pointing to. Now execution moves on to line number 2 and it simply returns the value is stored at the memory block pointed by result. Now at this point the add function gets removed from the stack and the execution of the function, which is now at the top of the stack, it begins from the line number where the control was moved to add function. So in our case it will be line number 3. And since the add function returned the value of 30, so a memory block for C will be allocated and let's say it has an address of 6000. And since the value returned was 30, so C will be having the value of 30. Now the control moves on to the line number 4, which simply prints out the value is stored at the memory block which C is pointing to, which is 30. And hence in our output we will see 30. Now that we know what goes behind the scene, let's dive into recursion. In programming, when a function calls itself, it is called a recursive function and the program is said to be using recursion. Let's understand this with an example. Here we have a function named print, and what it does, it takes in a number and it prints out its value and call itself by decrementing the value of num by 1. So let's look at it with an example. Consider the value 3 is coming in the num. Alright, so here is our stack And on the top, the first function is print. And we are passing a value of 3. So we will have a memory block of, let's say, 1000 having a value 3, and then num variable is pointing to this memory block. Now the execution of print function begins, and on the first line it prints the value of num, which is 3, and hence a 3 is printed on the screen. The execution moves on to line number 2, where a call to print function is made. So the copy of another print function will be pushed onto the stack, and this time we are passing a value of num minus 1. So in here the num has value of 3, and hence a value 2 will be passed on to this function. In here again, this function will have its own num pointing to, let's say, 2000 memory block, and the value it will have is 2. Now execution begins for this print function, and on the line number 1 it prints out the value of num, which in this case is 2, and hence it outputs 2. On line number 2, another call to print function is made, and hence another copy of print function will be pushed onto the stack, this time having a value of 1. Another memory block, let's say 3000, having a value of 1, and this function has its own num variable which is pointing to this memory block. Execution begins. On line number 1 it prints the value of num, and this goes on.
However, did you notice a problem with the print function? It has gone into an infinite loop. It will keep running until the machine runs out of memory to accommodate more print functions. It's equivalent to an infinite loop. To solve this problem, we need to include a termination condition in our recursive function. Just like we have conditions in loops, recursive functions also require a base case that determines when the function should stop calling itself. Let's see the correct version of the print function.
Continuing with the workout with the corrected version of this program, from here another copy of print function will be pushed onto the stack having a value of 0. Now this time around, when the execution begins, another copy of num will be made having an address of, let's say, 4000 and the value of 0. So on line number 1 we have a if condition which checks if the value of num is less than 0. In this case it is not less than 0, and hence it will not go into this if condition. The control now moves on to line number 3, which is to print the value of num, and in this case the value of num is 0, so 0 will be printed on the screen, and a call to another print function is made on line number 4. Since the value of num will be minus 1, so it will go in the if condition and it will return without doing anything. So once it returns, this print function will be removed from the stack. The control moves back to the function which is on the top of the stack, and the execution begins on the same line where the control was shifted. Now for this print function, since there is no more line, so this function will also be removed from the stack, and the process goes on. For example, now on this print function, since the control moved on line number 4 and there are no more lines, so this will also get removed, and similarly the other functions. And since there is nothing left on the stack, the program will gracefully terminate.
Now that we understand what a recursive function is and how to handle its termination, let's discuss why we need recursive function in the first place. Why can't we just use iteration? Well, the thought is correct. Whenever possible, we should go with iteration because recursive functions can be memory intensive. As we saw how each function call is pushed onto the stack with its own copy of variables. However, recursive functions have their own advantages. For example, recursive functions allow us to leverage the programming language's inbuilt mechanism to maintain state. This can be particularly useful when traversing trees and graphs, where maintaining states is not easy using iteration alone. As a challenge, I invite you to try writing an iterative program to traverse a tree in pre-order, in-order, and post-order. You will find that using recursion often simplifies these type of tasks. That's all for today's video. Thank you for watching, and I hope you found this explanation of recursion helpful. If you did, please show your support by liking this video, sharing it with others who might benefit from it, and subscribing to the channel for more informative content like this.